The next step then, as we said in the last video, is looking at other ways to do conditional jumps. In the appendix of your book, there are details for each of these instructions. Some jump only if certain conditions are met. So we're going to look at a branch if Z is equal to 1 and a branch if C is equal to 1. Conditional branches for the pick then are summarized in the table. As I said before, you can check Appendix A for more descriptions. So let's take a look at BZ or branch if Z equals 1. In this instruction, the Z flag is checked. If it's high, it jumps to the target address. So if we take a look at the example, we've named it over. We've done a move F to port B in putting it in the working register. So we read port B and put it in the W register. JZ over says jump if the working register is equal to 0. So in this program, if port B is 0, it jumps to the label over. So again, over is just a name. So it jumps to that label. It stays there until port B has a value other than 0. Notice with the branch if Z instruction can be used to see whether a file register or a working register is 0. More importantly, you don't have to perform an arithmetic instruction such as decrement to use the BZ instruction. So you see what we're doing here is we're building on these instructions. We go from instructions that can become very cumbersome in trying to use them. In each case, we add another instruction set that helps us to simplify things and make the programming a little more efficient and easier to flow and not make the code so fat. So if we take a look at an example where we're going to write a program to determine if the file register location at 0x30 contains a value of 0. And if it is, then we're going to put 55H in it. So we're going to check to see the status. We're going to look inside the register, see if the value is 0, and then put a 55 hex inside. So in looking at the solution here, we've got a label, my location, equated to 30, and then we're going to do a move to the file register where we copy my location then to itself. So although it's a move command, we're actually copying it to itself. The B and Z branch if Z. Next then is a branch. It's telling it my location is not 0. So if it's not 0, then we go next. The next step, move the literal from the working register 055. Move the working register to a file, my location, and at that point we have put 055 if my location is 0, and then back to next. Okay, so we've got a simple set of instructions here where we have placed a value and then checked it to see if it's a 0. If it is a 0, then we put a new value in my location. Okay. The BZ instruction then can be used to see if any file register or working register is 0. It doesn't require an arithmetic instruction to decrement to use BZ instruction. Next, let's look at the branch if no carry. So we looked at the Z flag. Now we're going to look at the C flag. With a branch if no carry, branch if CY equals 0, in this instruction, the carry flag bit in the status register is used to make the decision whether to jump. In executing the B and C label, the processor looks at the carry flag to see if it is raised or C equals 1. If it's not, the CPU then starts to fetch and execute instructions from the address of the label. If C is equal to 1, then it will not branch but will execute the next instruction below the branch if no carry. So if we take a look at an example, we can step our way through it and get an idea of how this works. So in this example, we're going to see how the B and C is used to add numbers together when the sum is higher than FF in hex. Note that there is also a BC label instruction. If the BC, in the BC instruction, if C is equal to 1, it jumps to the target address. We'll get more examples on this later when we move into chapter 5. Other conditional branch instructions then will be discussed in 5 at that time. So in taking a look at the code here, we're going to find the sum of the values 79 hex, F5 hex, and E2 hex, and put the sum in the file register locations 5, the low byte, and 6, the high byte. So the low byte here, we've identified it, we've equaled 5, assign the RAM location 5 to low byte of the sum. High byte, equate, okay, so again, these are just labels, equate to location 6, assign RAM location 6 to the high byte of the sum. Okay, so in this case, as we move through, again, we're going to initialize, we're going to move a value into the working register of 0. Move a working register file, the high byte, it becomes 0. Then we're going to add the literal working register 79 to that. So you can see here in the comments, the working register then becomes 0 plus 79 hex, which gives us a 79 hex. And at this point, the C flag is equal to 0. Then we're going to branch if C equals 1. Okay, we've got a value here, n underscore 1. If C equals 1, then we're going to add the next number. An increment command then says the high byte then and a file location. So if C is equal to 1, we increment, now the high byte equals 0, and then we've got two labels here, n underscore 1, n underscore 2, and then finally over. So in the n underscore 1 portion, we're going to add a literal to the working register 0 by F5. So the working register then becomes 79 plus this value of F5, which gives us 6E and a flag of C equal to 1. We've got a branch then if C and 2. Okay, so there's our jump if we need to, branch if CY equals 0. And then increment the high byte F with C equal to 1, increment, now the high byte equals 2. So it's adding up. Then in n underscore 2, we add the literal working register 0 by E2. The working register then becomes 6E plus E2 plus 50, and C, that's supposed to be C equals 1, not plus. In the branch conditional here, C equal 1, we look at the bailing out to our label over, which is down here. we branch if C then is equal to 1. C is equal to 0. So it's testing it to see at this point if C is equal to 0. Then we would increment the H byte with F. C equals 1. Increment. Now the H byte equals 2. Finally, then when we get to the bottom, the label over, we're going to move the working register, file register, L byte. L byte then now equals 50 H, 50 hex, and the H byte equals 2. Okay, and then we're at the end of our process here. So in each case, what we've done here is we've gone through and incremented and tested at each point until we reach the end and the low byte equals 50H. Okay, so just a quick example of using those two conditional jumps of a branch, testing at the Z and at the C flags.